Well, good morning, good afternoon, and good evening, everyone, wherever you may be, and welcome to this series of talks, the E3, Earth, Energy, and Environment. And first, I want to thank the organizers, Dr. Soliman and Dr. Garhi, for all the work they've put into putting this together, and everybody else who's been involved in putting this together. Honored today to be moderating a panel entitled New Technologies and Digitalization, and I'll be hosting three distinguished speakers here, Dr. Ahmed Zahabi, Dr. Sama Morsi, and Dr. Susan Nash, and let them say something about what they do now as part of their talk. But I want to thank them in advance and welcome them to this panel. I'll kick off with a couple of thoughts just to introduce the topics. It's a pretty broad and wide one, so difficult to cover or do justice in 1 hour. But I'll do my best just to paint the broad picture, and then we'll have the panelists really expand a little bit on some subset of these topics. So looking a little bit at the big picture here, sort of the mega trends, what I think is apparent to everyone, particularly younger folks who basically lived in the last 3 decades, is the exponential rate of change. Not that change is new, of course, change has never been new, but change is sort of the new constant, if you like. So there's just been an acceleration of that rate of change. And you can see that manifested in many ways. If you see at the bottom here, I have a couple of slides sort of demonstrating this exponential nature of change. For example, this one looks at the computing power. So the number of calculations per US dollar, so 1,000 US dollars per second, have gone from the early 1900s in the case of the analytical engine to some minute fraction per second to 20 billion calculations per second per $1,000. So that's a change of about 3.5 quadrillion times in 100 years. And note that the majority of that change, or the exponential part of that change, has happened in the last 50 years or so. Similar, even maybe more compelling example is to look at the cost of genomic analysis, okay? I mean, we're obviously in this era of COVID, so this is very familiar to everyone. But if you look 20 years ago, in the early 2000s, the Human Genome Project took 13 years and cost $2.7 billion to complete. It was a humongous effort. Today, you can do the same thing in 15 minutes and less than $1,000. I mean, it's just, mind-boggling how much change has occurred in these 20 years. So if you look at the mega trends that are really going to impact us, not just today, but really into the next decades, urbanization is going to be a big deal. The concentration of people, and that's been ongoing, is just going to accelerate now. The concentration of people in cities and what comes with that in terms of changed habits around mobility, consumption, and other things. The changing demographics. As a rule of thumb, the world is aging, notwithstanding few places in the world where there is still increase of younger populations, mainly Africa and parts of Asia. On the most part, the world is aging, okay? So that comes with certain changes in consumption behavior and other things. Digitalization, which is something we're going to touch upon today and give you some examples, has really changed a lot of things, not just from the technological side, but actually from the business side. And then energy transition, which I think is very familiar, is a topic of some of the other panels, but very prime topic today, with what's going on in Glasgow the last couple of weeks. So I'll just leave you with this thought that the basis for the global economy has changed a lot over the last several years and will continue to change a lot. So if there's one message I would like to leave you with, is embrace that change, as opposed to, get alarmed by it and so on. Change will be an integral part of our lives. So the more you understand that change and embrace it, the more I think you'll be comfortable and making the best of it, as opposed to sort of deny its existence. And you need not look very far away from even the economy itself has changed a lot. So we've gone essentially from a manufacturing-based economy where physical assets are the most important. Most companies are run with a top-down management and book value matters the most, to a knowledge economy where human capital actually is the most quintessential. Most organizations are becoming flatter, and revenue per employee or stock options are the ways to reward folks instead of gold watches. I remember that when I was about to retire from Schlumberger, the gold watch was a quintessential, target. No longer is that the case. And also, if you look at, just as a demonstration, the Fortune 500 companies, in 1970, they were mostly industrial companies. General Motors, GE, Exxon, Kodak, and IBM were at the top. In 2020, it's a very different crowd, and very few of them actually have any physical assets at all. Amazon, Microsoft, Apple, Google, and Facebook, very familiar to all of us, don't own a whole lot of physical assets. So I'll leave you with that thought. Embrace the change, and introduce our next speaker, Dr. Ahmed Alzahabi. He's with the University of Texas at the Permian Basin, and he will be walking you through some of the very interesting work he's been doing on analytics. Dr. Ahmed, over to you, and let me know when you want to advance the slides, please.
Good morning, everybody. Thank you so much, Hani, for the invitation. Thank you, Dr. Agarhi, Dr. Solomon. It's such a great honor to me being here today among a group of talented colleagues and present some of the work that we have been doing in the past, utilizing some of the analytics work. So a core element of oil and gas digitalization, especially in this sector, is the Internet of Things and big data. The so-called Internet of Things is where objects and equipment such as sensors interconnect and transmit digital information. It generates vast volumes of data, what's called big data, at various velocity, arriving at high speed, and with a variety of formats for the main purpose, which is decision making. Advanced big analytics or data analytics includes models and algorithms that provide invaluable insights for the industry. This leads to new business opportunities and, of course, models that can be used and services that can be introduced to the end user customer. The four biggest digitalization priorities for oil and gas companies now: cloud-based applications, data platforms, AI, and blockchain. So, for an example, single drilling rig in West Texas can generate terabytes of data every day. Big portion of it is not being used for decision-making process, and simply this can be a barrier. And for each stage of the workflow, as you can see, data integrity can be an issue. Data streaming may not be accessible for engineers and for the team. Data may not be analyzed even if you have the right model. Data may be not communicating through the proper channel. And the big barrier is data not used in any of the decision-making process. Next, Hani. And so this slide shows one of the example or the case studies that we have been working on in the past. An oil and gas company approached our team, and they wanted us to build a scale to measure well performance. They also wanted a tool to decide on completion parameters, in addition to correlation between initial production of horizontal wells and a few key completion variables. So we used one of the data analytics tools, response surface methodology, and it is a statistical tool that simply explores the relationship between several variables and on the response of another variable. So the main idea is to use a sequence of designed experiments to obtain an optimal response. So try to understand which one of the variables for the completion aspects. We were looking for 280 variables downhole completion aspects, and we were trying to figure out what is the optimum data that we should depend on when we compare productivity of wells. When we ranked them, we figured out provenance in pounds per foot, number of clusters in a frac stage, fluids and barrels, in addition to completed feet, and the number of stages are the top variables that impact your initial production. So if you want to pick the variables that impact your future initial production of horizontal wells, especially for this situation, Wolfcamp case, you're going to find provenance in pounds per foot comes first. So the higher the provenance in pounds per foot, the higher the expected initial production from your horizontal well. The clusters and the fluids, completed foot, number of stages comes next. But these are the top ranked 5 variables out of 200 plus variables that impact your horizontal well initial production. Next, Hani, please. So the findings of this study simply that optimal production is guaranteed by maximizing some pairs of variables, including cluster spacing and the provenance. The model that was built as part of the process used to predict initial production for horizontal wells of the Wolfcamp using, as you see, few completion variables. Big data is used in this part, and it is a key in lowering cost, reducing downtime. So over the long term, you can maximize your initial production and reduce sand and water production. At the same time, you can maintain your well productivity, and it was really more effective in monitoring. So the trend now in the industry is to strive for continuous downhole data gathering, whether for injection, production, and observation wells, based on permanent downhole gauges. This allows decision making in real time or near real time optimization in rates, especially in several zones or selected zones as part of smart well or intelligent well system. So the response surface methodology give us a chance to explore the relationship between several variables and to try to maximize some of these variables combined to see the impact on initial production. So, for example, cluster spacing and the provenance, when you maximize them within certain ranges, this simply led to increase in the initial production of the horizontal wells. Another example, but it is not brought here today, is trying to optimize drawdown of horizontal wells. Another company gave us 26 horizontal wells from Anadarko Basin, and they were trying to optimize the drawdown from horizontal wells. So simply, the higher the drawdown, the higher the production to a certain limit. So if you keep opening it shop and being up, which is well-known methodology for oil and gas operators, you produce more hydrocarbons. On the other hand, you have the chance of producing more sand and more water. So what is the optimum range that really gives you the maximum production without hurting your longer-term strategy? So we used smoothing as part of the data analytics tool as well to give them the optimum range for drawdown for the 26 horizontal wells, and the optimum drawdown for these wells came to be around 52 psi per day. So this is going to be your optimum drawdown if you are looking for initial production impact and the long-term estimated ultimate recovery as EUR. Hani, please. So this simply is telling you the future of oil and gas industry. If you pay attention here to this diagram, start from upper left picture, you have first item is sensors installed downhole in the wells, sensors around the rig, around platform of production, deep Gulf of Mexico. Sensor transmit data, mainly including temperature and pressure. Number 2, in the workflow, it comes the engineer in the office, receives alerts, and he performs quick diagnostics. And he has some screens in front of him to simply interactive 3D models. Comes item 3A. So as you have an issue, then you have surveillance drones offshore drones investigate and simply share live photos and the videos in real time. Then come 3B, which is real-time request, and you have certain approved vendors by the company, and automatically the system pick the vendor for what is the problem there. Then comes item 4, which is real-time analytics. Here comes the big data rule and the maintenance based on the surveillance data and integrate supply chain or the parts. Then comes point 5, smart devices. Engineers are equipped with mobile devices. They have watches, and they simply real-time prepare for the surface. Then comes item 6, which you have 3D printers, and which is part of your manufacturing center in the job location. So you manufacture the piece if it's available in-house. Then comes the delivery drones, item 7, offshore, onshore delivery drones deliver parts from the warehouse to the offshore rig. Then comes item 8, tablet, smart glasses. Engineers utilize virtual modules on tablets and augmented reality data on smart glasses to make sure the job was taken care of. So I frequently get the question, what is gonna happen in the next 10 years? This is a common question. I always don't get the question, what is not going to change in the next 10 years? So I confess the second question is more important than the first one, because you can build a business strategy around things that are stable in time. In oil and gas operations, you would never see a customer who is coming to you ask for more expensive gasoline. You will never see a customer who's coming to you ask for less hydrocarbons or a slower piece of drilled well or less number of drilled uncompleted wells. So this would never happen. So our rule in this industry is to collaborate. So I see a collaboration between, not just between engineers, I see a collaboration between a machine and the human being. So as an example, the next group of petroleum engineers, they will see opportunities was not available before, where human and the machine collaborate. So we have a robot is taking care of drilling the next section of the target formation, and another robot is taking care of analyzing completion data. A third robot in the job location is taking care of preparing mud pits and doing the mud calculations. And your petroleum engineer job is gonna be oversee these tasks together and make sure they work in synergy. So this is the future, how I see it. That's it. And now I leave the stage for Dr. Sama Morsi from ResFrac.
Thank you, Dr. Zahabi, and very interesting insights there. Okay, well, now over to you, Dr. Sama Morsi, and you're with ResFrac. Over to you.
Thank you, Hani, and thank you, everyone from the organizers. Really appreciate the opportunity to speak to you here today. Following slide, please, Hani. Yeah, so it's exciting to think about the new technology that is coming to impact everyone and how we can, as an oil and gas industry, can help also other industries to grow. And today I'm going to talk to you about how emerging oil and gas technology, how we can transfer. Do you see I don't see my video, is it okay? Do you see it?
It's fine. Everything is fine. Just keep going.
Okay. So yeah, so today I'm going to talk to you about how emerging oil and gas technologies can transform enhanced geothermal systems. If you are aware of geothermal systems or geothermal resources, it's basically, you need to have three main components exist in order to have a good resource of geothermal. First one is you need to have a hot rock, so you have a high temperature in the reservoir, you need to have a good permeability, and you need to have fluid that you can produce at the surface to harvest that heat. So that was the typical kind of geothermal resources available around the world. And if you think about these three categories, you will think that these resources are very few around the globe, and mainly in Italy, Kenya, Indonesia, US, and very few countries that have that kind of complete kind of resources of geothermal. That was a typical kind of geothermal resources, and that was kind of, a limiting factor for that industry to grow. Right now, with the new technology and smart people thinking about how we can do to improve these resources or even to create these resources. So you come to a point that you have hot rock, as you all know, when you drill deeper into the rock, under the ground, the deeper that you go, the hotter that you find these rocks. So you will find hot rock everywhere in the world. However, some of these hot rock, they are not permeable, so they don't have good permeability, and some of them, they don't have fluid in them, so you cannot harvest heat from them because they don't have any fluid to produce to the surface. And as I said, permeability as well. So in order to overcome this kind of limitation, the enhanced geothermal system came in hand, and it's basically a man-made reservoir. If you think about it, you have a hot rock, but you don't have fluid and you don't have permeability. So that kind of situation reminds me of shale development in the beginning, or like I would say not far from now, maybe like 15 years ago or so. All of us were thinking as petroleum engineer of shale as an unpayson, right? Everybody bypass that shale layer and go to a sandstone or carbonate layer to develop and produce oil and gas. Never think that shale can be, a pay zone that you can produce from. But with the new technology of combining hydraulic fracturing with horizontal drilling, that make it real, that transform shale from non-pay zone to pay zone. You generated permeability into the rock, and you generated that reservoir that you can produce from. So we can do the same to geothermal system. Every country has that rocks that are hot rock at deeper depths, but they are not utilized to be potential geothermal resources, right? So we can transform these hot rock that doesn't have permeability, doesn't have fluid, into a really a good resource that can produce and harvest this heat and transform it into electricity. And the way to do that is to just adapt to what we have been developing in oil and gas into this industry and use all of these technology to make it profitable. So if you think about a shale, or a geothermal rock or a hot rock that doesn't have permeability, doesn't have fluid in it, what we can do, we can drill horizontal wells and we can frag them. And by doing that, we are generating or creating permeability into that rock. And at the same time, we can have injectors where we are recycling water from the surface to the producer. And that way you can introduce also fluid to these systems that are dry, that they don't have any fluid and they don't have any permeability. So you can create a man-made reservoir here into geothermal. And that's going to be really a big transformation to this industry, because you can generate as much as you can everywhere, and every country can have that kind of technology to explore and to get more out of that system. The other challenge that used to be a big limiter for geothermal around the globe as well was that you are producing from a very hot rock, and sometimes also these resources also has higher pressure as well. So higher pressure, high temperature. Not every casing that you're drilling with can sustain this high heat and high temperature, but with the big also technologies that we are developing in oil and gas for deep water project in Gulf of Mexico and worldwide, we were able as industry, oil and gas industry, to actually be able to produce fluid from such hot rock and high pressure, and kind of advance the metallurgy or material that you are using for having such pipe and casing to produce from hot rock. So that's another thing that we bring to this industry. Following the slide, please, Hani. So we kind of cover the operational aspect of the problem, like how we can transform it operationally by doing horizontal drilling and hydraulic fracturing, and use some of these, material that we use for deep water reservoir. But now we come to the point that yes, you can operationally do that, but also you need to have advanced softwares that can enable you to optimize these resources as well. Since we are bringing hydraulic fracturing and horizontal drilling, as Ahmed Zahabi, he was giving his talk about, how to optimize shale wells, right? It comes to cluster spacing, how much fluid that you're pumping, how much proppant, and what is the spacing between the wells, what is the cluster. All of that we will be carrying over into the geothermal, enhanced geothermal, because we're going to leverage all of this learning from shale development into enhanced geothermal system. So what you're seeing here in this screen is basically a producer, two wells. One of them is used as producer and the other is injector, and they are laterally apart by maybe 1,000 feet or so. And what you're doing, you are fracking the injector in a way that you connect the injector to the producer, and then you inject the water from that injector and recycle it to the producer, and you so on. You recycle this water more and more, and you harvest the heat at the surface, and you convert this heat into electricity. So you need advanced software, as I mentioned, in order to help you optimize this technology. One of the software that is available right now in the market is ResFrac. It's being used by oil and gas operator to optimize shale development, hydraulic fracturing, geomechanics, all of such kind of stuff with reservoir engineering. And we also have the capability to do it as well for enhanced geothermal systems as well. So you can adapt the same technology and optimize geothermal wells. And to give you just an example of how much heat that electricity that you can get out of only 2 wells development in geothermal, that's, for example, 2 wells that are apart by about, as I say, about 1,000 feet. These 2 wells can produce about 29 megawatt electricity. And the reservoir rock here is about 400 Celsius. And if you think about how much this electricity that you're generating can support how many residents in US, for example. So every resident in America, they consume about 11,000 kilowatts per year. So this means that the 29 megawatt can actually support or provide electricity to about 23,000 residents. And that's a big, really, breakthrough that we can do through this technology. So that's pretty much of all what I have for you today. I hope I take only the 10 minutes as allowed for me.
Thank you.
Yeah, welcome any question or comment. Thank you.
Thank you, Dr. Sama. Now, moving over to Dr. Susan Nash with AAPG, and she has also some very interesting insights to share with us on some technologies here. Susan, it's you.
Hi there. Well, it's really an honor to be here. I want to express my appreciation to Dr. Elshahawi and also to Dr. Al-Garhi, and for organizing this event and making it such a positive thing. So today I'm going to be following up and tying in a lot of the materials that we heard before. And one thing that I think is quite interesting is what Dr. Elshahawi said earlier. She was talking about how change is a constant and there's nothing to be afraid of. Actually, I've always felt like change is an opportunity. And it's funny too, I've often thought too that change that results in upheavals or sort of downturns, when I look back, I realize, wow, I had my biggest breakthroughs during those times. And so because it encouraged me to let go of things that I was clinging to or working on that were eating up my time, and it gave me time to change. So that's always a positive. And one of the things that we're seeing with the technology change, with an emphasis on changing from carbon and also changing from being places in person, both precipitated by scary negative issues, climate change, and also COVID. But then we're seeing that with human creativity, we're able to do more with less and think about ourselves in a more collective way. And it's kind of interesting that where we're talking is almost like in the intersection between the real and the not real, and the idea of using remote sensors and remote techniques to develop images either on the surface or subsurface. What we have to keep in mind is that they actually do have an objective correlative. They really do matter they do have a real life counterpart. So when all possible, it's really important to continue to go out and seek the kind of ground truth or reality truth to not only get in touch with what we're really working on, but also to improve the models, the mathematical models. So how many of you are kind of aware of all the new satellites that are going up in the air and what they can do now and the resolution? The thing that's interesting is we used to think of satellites as sort of like Landsat, only kind of big picture, the false color composites, you could just see sort of trends, et cetera. Now the resolution is a lot higher. And also, how many of you use Google Earth? There's a great example of open access Earth images. They're perhaps not high enough resolution or accurate enough to use in some of the better models, but they're a good start. And also imagine all of the GIS systems that you use that have information that's been gathered by satellites. It's incredibly important. And one of the things that I think people often overlook in engineering and also in geology is, and it used to be required, I'm not sure that it is anymore, is to take a geography course that talks about landforms. It also forces you to learn how to use GIS systems. ArcGIS is probably the most commonly used. And so then you can use the information for all kinds of things. And then also using sort of Earth imaging in the case of drones. So we think about how you get the actual information. You get it from the sensors that we'll talk about in a second, but there are different types of sensors that can be used. And in the past, the key one was photogrammetry. And the downside with that is that it uses a lot of memory. And so even though like the actual flight of the drone might be, say, 30 minutes maximum, sometimes the capacity of the chip or the onboard chip is like, and usually they're not actually streaming up to anything. It's many times onboard, it's kind of exceeded. But with other kinds of sensors like hyperspectral and multispectral, it's much more, it's actually, they're much more efficient and you're not likely to run out of space. So drones are used now in ways that were not used before, just simply because of COVID and people having to make a lot of decisions to monitor the condition of things, monitor like, for example, conditions of roads, of infrastructure, but also using them for vegetation as a proxy for different kinds of contamination, fugitive emissions of natural gas, et cetera. And then finally, I don't know how many of you are familiar with the concept of smart cities, but fiber optics have been placed in a lot of different cities. And by using the fiber optics to measure changes in the basically in the transmission of light pulses, it can, as a proxy, detect vibration and micro vibration. So distributed acoustic sensing, or DAS for short, has been used for like passive seismic, for determining if there are any hazards, if there are any, if there's any vibration in a building or a structure that could suggest that it needs to be structurally reinforced, or also for determining seismicity, induced seismicity, for example, in injecting water in different places. So produced water is injected into wells for disposal. Also, geothermal systems inject a lot of water. And the thing that we have to be aware of is that geothermal systems have triggered many earthquakes, especially when you consider the number of geothermal systems there are. So it's incredibly important to look at hazards and be aware of potential dangers. So just wanted to say that in learning how to do these things, if you learn how to develop algorithms, et cetera, for machine learning, and those are all used in conjunction with the sensor data, you will be identifying patterns, and you'll also be identifying behaviors. So the patterns will help you with classification, identification of whatever it is that you are looking at and looking for. And the pattern behavior will help you, and in terms of behaviors, will help you with prediction. So anyway, just some examples of how drones are being used right now in kind of unique ways. This is a really interesting one that I really like. The company is Drone Geoscience, and they're in Colorado. And they have been using sensors, magnetometers on extremely low altitude flights. And they've been able to find kind of lost oil and gas wells and also pipelines. So what will happen is that in old wells, they will say, for example, it's in the center of the northwest, southeast quarter. This is like using the township and range system is found in certain states in the United States, or you'll have it's not exactly precise. Even if you have latitude and longitude, it may be a little bit off. So if you have to go and find this well, you really need a more precise location. So they've been able to do things like locate wells in like 4 hours. So it's kind of amazing. And you can see where the actual location is versus where it was like historically placed. I'm ready for the next slide, please. So another thing that we can use with in the new world, it's very important, is to use Earth imaging for identifying and remediating encroachments and other hazards. I don't know if any of you happen to look at the news. The island nation of Tuvalu in the South Pacific got into the news today because it has a total, the highest point in the island is 15, well, I think it said feet, that can't be right, maybe meters over sea level. And people are actually living on this island, which doesn't seem like a lot of protection in times of storms or tsunamis, et cetera, storm surge, et cetera. But it's getting worse. So with sea level rising, the people in Tuvalu said we are living out the consequences of global warming. And so in order to plan for the future, they have to be able to identify exactly what is happening and how quickly it's rising, where they are, et cetera. The best way to do that is Earth imaging. And that there's it's also a good way to do it, not just for a specific case, but in general, like mapping out and using it for planning purposes. So as you monitor operations and detect possible encroachments, then you can make recommendations. So if you see yourself as a petroleum geologist or petroleum engineer, you can also see yourself as an environmental engineer and take steps to be able to apply your skills across the board. The next slide, please. So again, just thinking of future applications in cities, and especially the so-called smart cities, we're going to see more and more examples of distributed acoustic sensing. There are already applications of fiber optics in pipelines and also in wells. The problem with it, though, is that it's expensive. So as time goes on, it's important to identify exactly where and how to use them. So again, as you look at your career, I think the key is to be clear-headed and identify risks and problems and where potential shortages, potential destabilization, do a needs assessment of the world, basically, and then match your credentials and abilities with a way to propose a solution and actually start to implement it. And I've always thought that a really good way to start is to actually write your own white paper, identify a solution, a problem, and then put together a workflow for solving that problem, and then publish it yourself in your blog or wherever, and point to it in your LinkedIn profile. And you can publish an article in LinkedIn. I would break it up into small pieces so that you have part 1 through 20 or whatever, so people have like 90 seconds to read will read it. But I think that that's a really good approach for the future, especially as we see all different kinds of technologies used to solve emerging problems and opportunities and changes. I think that's my last slide.
Thanks, Susan. Appreciate it. Yeah, no, thanks very much for the insights in general. And if you can all come back with your cameras on, I'd like to take a few questions. We have time probably for 3 or 4 questions. So I'm going to direct one to each of you. I've kind of collated some of the comments. And Malcolm, thank you for summarizing these. But let me direct one to you, Dr. Zahabi. Can machine learning help with well maintenance or otherwise equipment maintenance schedules? For example, equipment that need to be repaired so that you can optimize the turnaround times and or maintenance schedules. So question is related to that, yeah.
It's a good question, Hani. So it depends on the problem specifically. So very similar to that question, I think it was the first question I just answered by retyping in the chat answer to the question. So machine learning is such a broad area that every problem is unique. Every problem requires certain way of handling. For example, the case studies that I talked about, which is optimizing initial production. We used the ranking, which is a standard statistical technique. We used RSM, which is response surface methodology, because we are looking for certain specific problem. So for scheduling, must be some tools available out there to handle the scheduling. There are also industry software available to handle the scheduling, whether you mean drilling, operations, or production. Yeah, I'm aware of some commercial software, and I'm sure Hani have seen during time at Shell as well, multiple software available to take care of this one, which of course the software is based on a certain algorithm, and in the background they have the algorithm programmed in a way that gives you as user easy handling of drilling operation or maintenance. But the last slide that I was talking about, I'm talking about the future vision. I'm talking about fully operating a system that may happen in hopefully 5-10 years time frame, where you have everything in the location, and even you have your manufacture center with the 3D printing. So even vendors will not need a vendor because you have your manufacturing center at your place. So I hope I answered the question. But it is a challenging problem. Like every problem has its own challenging. And first you have to define the problem, formulate the problem to see what tools you can fit in.
I will check if Hani get disconnected. Yes, so yes, you are back.
Apologies for that. That's some of the beauty of being virtual. Another question I wanted to direct to you, Dr. Sama, has to do with the economics, the economic evaluation, compare, contrast between EGS, other methods of geothermal, closed loop or other, with, let's say, oil and gas. What methodologies exist to be able to make those trade-offs and comparisons today?
Yeah, that was absolutely right. That was one of the biggest challenges for geothermal, because you need to drill deeper into the rock, and that the cost of drilling and completion is a big part that actually the Department of Energy is trying to overcome right now by looking at what other methods or kind of cheaper way to do that or to advance geothermal. One of the methods that I think can be really a good start for advancing enhanced geothermal is actually utilizing abandoned wells, oil and gas wells. That way that you have already the vertical well is already drilled and it's idle, so you can re-enter that well and you can do some sidetrack and frac these sidetracks and utilize the whole system that you want to do. That way you're gonna I would say maybe you can cut your cost maybe to 50% of your drilling cost, because you're gonna be just drilling the lateral part of these wells, not the entire vertical section, which is cost a lot of money. So these are one of the ideas right now, and I see some of the startup companies that are starting to talk about it and actually get a good response, and I see that can be a good really way of doing it.
Thank you. One more question to you, Susan. Maybe we'll wrap up with this one.
Okay.
And I think you talked abundantly about that, but just sort of doubling down on the same. What would be your advice, for a graduate student or of, petroleum engineering to obtain additional competency, whether it's data or other ways to position themselves in the future?
Well, I think that one of the things to do would be to make sure that you have at least one machine learning course that includes using programming in R or Python. Just, you don't have to become an expert, but understand it. And then also make sure that you understand geospatial systems. So GIS, of course, so you can create maps and simulations. And then I would think something that has to do with the big picture of project management or urban development, something like that would be really important in being able to not just do facilities management, but also apply it to the overall urban landscape.
Thank you, Susan. And there's actually a group of questions that have to do with, job availability and the rest of that. I think that will be covered in some of the other panels. But I'll just maybe leave you with one thought, which is digitalization is fundamentally about not just changing, the technological tools that you use, but really changing the way you do work in the first place. And part of that change is to automate a lot of the tasks that traditionally were manual or mundane tasks, repetitive tasks that don't add a whole lot of value, and focus on the more value-adding work. I think Dr. Zahabi alluded to some of that already. So the nature of the work actually changes with digitalization. It's not just a tool or a methodology to take what's done manual and do the same thing digitally, but you continue doing the exact same nature of work. Along the same lines, it also dilutes the traditional silos that have existed. So when you want to think about a petroleum engineering career or a geoscience career, or any career for that matter, I think one thing you have to maybe get your head around is that it'll change. It'll change too. Those boundaries will change. It will become a lot more fuzzy. And the idea of continuing to learn throughout your life and continuing to unlearn some things that you might have learned, that you need to learn new things in place of, will be a thing. In fact, it already is a thing. And in the future, it will become even more important to think of lifetime learning and acquiring of capabilities throughout your career, or let's just call it your working life. Maybe the word career also become outdated. But I want to thank you all for all your insights and all the wisdom you've shared with the crowd here, and really appreciate your time and expertise and your insights. Thank you very much to the audience as well, and thanks again to Dr. Garhi, Dr. Dr. Ben for all the good work that they put into. Thank you very much.
Thank you. I know people were from Azerbaijan. I went to say hello. I went spend a lot of time there.